Pluto, a tiny world billions of miles away, was once a celebrity in our solar system. It held the coveted title of the ninth planet, captivating our imagination. Discovered in 1930 by Clyde Tombaugh, Pluto fascinated astronomers and the public alike. We knew so little about it, yet it intrigued us with its mysterious presence. Then, in 2006, the International Astronomical Union redefined what it means to be a planet. This decision had far-reaching consequences, especially for Pluto. Pluto was demoted to the status of a dwarf planet, changing its cosmic identity. Despite its demotion, Pluto remains a fascinating world, full of mysteries waiting to be uncovered. The decision to demote Pluto wasn't arbitrary. It was a result of extensive research and debate among the astronomical community. It stemmed from a growing understanding of our solar system and the need for a more precise classification. Astronomers were discovering more objects in the Kuiper belt, similar in size and orbit to Pluto. The IAU needed a clear definition of a planet to avoid overcrowding our solar system. After much deliberation, the IAU voted on a new definition of a planet. A planet must orbit the Sun, be spherical, and clear its orbit. Pluto met the first two criteria, but failed the third, leading to its reclassification as a dwarf planet. Pluto was discovered in 1930 by Clyde Tombaugh, and for decades it was celebrated as the ninth planet. However, as our knowledge expanded, so did the need to refine our definitions. The debate was intense, with many astronomers arguing passionately for and against Pluto's planetary status. The public was also deeply invested, with many feeling a sentimental attachment to Pluto as a planet. Ultimately, the IAU's decision was based on scientific criteria, leading to Pluto's reclassification as a dwarf planet. Pluto's orbit is one of the most unusual in our solar system. It stands out due to its unique characteristics. Unlike the nearly circular orbits of the other planets, Pluto's orbit is highly elliptical, varying its distance from the Sun. At perihelion, Pluto is closer to the Sun than Neptune, leading to interesting gravitational interactions. At aphelion, it's billions of miles farther out, deep into the outer solar system. Pluto's orbit is also tilted, adding complexity to its path. While most planets orbit on a flat plane, Pluto's orbit is inclined by about 17 degrees. This unusual orbit is a key reason why Pluto was reclassified. It shares its space with other icy bodies in the Kuiper belt. The Kuiper belt is a region beyond Neptune filled with icy bodies, and Pluto is just one of many objects in this distant area. This reclassification to a dwarf planet reflects its shared space and unique orbit, distinguishing it from the traditional planets. Pluto's relationship with its largest moon, Charon, is a marvel of the cosmos. Charon, discovered in 1978, is so large that they form a double dwarf planet system. They orbit a common center of gravity between them. Imagine two people holding hands and spinning around. That's Pluto and Charon. This unique relationship highlights the gravitational forces in our solar system. Please comment below with the correct pronunciation of Charon. A realm of ice and shadows, Pluto's surface is a frigid expanse of ice and rock shrouded in perpetual twilight. Temperatures hover around -380 degrees Fahrenheit. The surface features nitrogen ice plains, water ice mountains, and craters. A hazy layer scatters sunlight, giving Pluto its reddish hue. Despite its size, Pluto is a world of surprising complexity. New Horizons, a mission of discovery. In 2015, NASA's New Horizons spacecraft made history by visiting Pluto. The flyby provided us with unprecedented close-up images and data. New Horizons revealed a dynamic and geologically active world. It showed us towering mountains that may be cryovolcanoes. The mission transformed our understanding of Pluto, showing us a world more complex than we ever imagined. Section 7. Pluto's unexpected complexity. Pluto's demotion to dwarf planet status initially sparked disappointment among some. However, it's essential to remember that Pluto didn't change. Our understanding of it did. Pluto's demotion was not a demotion in scientific value. Section 8. The IAU's definition of a planet. The IAU's decision to reclassify Pluto aimed to bring order to our understanding of the solar system. Their definition of a planet aimed to create a clear distinction between planets and other celestial objects. The three criteria, orbiting the Sun, being massive enough for hydrostatic equilibrium, a round shape, and having cleared the neighborhood around its orbit, were intended to be objective and measurable. Section 9. Dwarf planets, a new category. The reclassification of Pluto led to the creation of a new category of celestial objects, dwarf planets. Dwarf planets share many characteristics with planets but are smaller and haven't cleared their orbital neighborhoods. Pluto is not alone in its dwarf planet status. The recognition of dwarf planets acknowledges the diversity of objects in our solar system. Section 10. Pluto's legacy inspiring future exploration. Pluto's demotion has sparked greater interest in the outer solar system. The debate has inspired a new generation of scientists and space enthusiasts. The New Horizons mission has provided invaluable data for future discoveries. Section 11. Pluto. Still fascinating, even without the title. Pluto, once the 9th planet, may no longer hold the title, but it remains captivating. Its demotion was an opportunity to learn more about our solar system. Pluto's story reminds us that science is about continuous discovery and adaptation. So, remember Pluto, the little dwarf planet that could, always inspiring curiosity. If you watched this long, please like and subscribe.